Hello, everyone. My name is Sergey Chuprov. I'm a second-year PhD student at the Rochester Institute of Technology, and today I want to present my poster titled as Are Machine Learning Image Classifiers Robust to Medical Image Quality Degradation? The authors of this paper is me, Akshaya Satan, and Leon Reznik, Professor of Computer Science, and my supervisor. So we're all affiliated at the Classifiers College of Computing and Information Sciences at the Rochester Institute of Technology. So the major idea of our work is to investigate how open source and well-known machine learning models are robust to image quality degradation. So as you know, machine learning systems are being integrated today in many different areas of our human life, and medical area is one of them. Actually, in medicine, machine learning and systems can be used for different things, like diseases recognition, treatment prediction, drugs prescription, and many other things like to support the doctor's decisions. In our work, we decided to employ three well-known, pre-trained on ImageNet machine learning models, such as VGG16, ResNet 50, and Inception V3. So VGG has the most deepest architecture, and ResNet 50 and Inception version 3 has kind of similar architecture, which you can dive deep in our work. We have a kind of more detailed description of these models in our paper. And we also consider machine learning and systems with integrated network inside of these systems. I will try to provide an example. For instance, you have a couple of sensors which measure some kind of information. They transmit this information over a network to the cloud server, and on the cloud server there are machine learning and system which need to classify this data or recognize any objects in this data depending on the kind of data which you use. For example, it can be any type of data. It can be images, it can be voice, it can be sound recordings, it can be X-ray scans like in our work, and it can be any type of data. And the network conditions during the data transfer from these data sources to the cloud-based machine learning and system can actually affect the data, the quality of the data that you transfer. For example, the attacker can provide a network attack on the network, and it can lead to the packet loss. And if you transmit that data with UDP protocol, you definitely will lose some packets there to transfer, and then you, on the receiving end, you have incomplete data, which is not very good for the machine learning system, which I will cover a bit later. So, as I said, we took three machine learning models, which are very popular in the community, and to establish a real network, we employ Powder Platform. Powder Platform is real terrain network facilities which are located and maintained by the University of Utah in Salt Lake City. So if you want to use them, you can just go on their website. So you can just type Powder Platform in Google and go on their website and read some information how to use their platform for the network wireless research. So actually we established a network between the two nodes. One node was data sources, and the second node was machine learning and system actually, and we transferred our images from the data sources to the machine learning and system over a wireless network. And in the process of their transferring, we varied packet loss from 1% to 25%. So actually, the major contribution of our work is the revealed interrelationship between the network quality of service and machine learning image classifier performance. Actually, yes, network degradation can also drop the quality of machine learning and systems. Actually, I will cover this a bit later in the results section. A bit about the dataset which we employed. In our paper, we employed the chest X-ray dataset that is used to identify the positive cases of pneumonia. This is a widely used dataset which contains more than 5,000 observations, which are partitioned on a training set, which contains almost 4,200 images, a validation set, almost 150 images, and a testing set, which contains 424 images. So the examples of the images you can see on the right side of the posters. So we have original images which contains X-ray scans of the normal lungs without any pneumonia and any suspicious things inside the lungs, and the original images with opacity in lungs, which we call abnormal in this paper. So also to decrease the risk of machine learning models overfitting to the training data, we perform a small training data augmentation process. We resize the images, we crop them, we rotate them, and yeah, that's all things we use to augment the data. In our empirical study, as I said, we established the network between two nodes. We transfer the images from one node to another, and we vary the percentage of the packet loss from 1 to 25%. So we experiment with 1, 2, 5, 10, and 25% of packet loss. So the greater packet loss is not really common. It might be if you have a DDoS attack, for example, in your network, but it's really rare that you have more than 50% of packet loss. So actually, for network communication, we employ an unreliable UDP protocol because we consider, for example, if we have some kind of limited resource network where we should not use a large amount of resources, which actually TCP protocol requires to establish the connection and acknowledge the receiving of the file. Okay, so, and after the image transfer, we submit these images for the classification by our employed machine learning models. Okay, we are going to the second part of the poster, to our results. As you can see, all the employed machine learning image classifiers suffer from data quality degradation in medical images. VGT16 performed slightly better than other two on in the initial case with the original images in 1% and 2% to 5% case, but then slightly degrades and performed worse than ResNet on 10%, but then we can see that here is a slight increase in the performance, but it's almost the same that ResNet 50 demonstrated. So from this, we can see that the more degradation we have in the images, the more pixels and the more data are slightly modified or lost in the process of data transfer, the more decrease in performance we have. So yeah, it is a common trend for all the considered image classifiers. Okay, so we can go to the conclusions of our paper. Even a small packet loss rate can result in a considerable decline in machine learning medical image classification performance. Yeah, as you can see, we we can say that depending on a medical image classification system, only the backend loss of less than 1% could be reliably tolerated. Other considered machine learning image classification systems fail when packet loss reaches from 2 to 5%. What we can recommend in this case? We can recommend employing VGG16 from our considered examples that demonstrated more robust performance on corrupted images against the considered ResNet 50 and Inception version 3. And to reduce image quality degradation, our rule of thumb will be when the packet loss reaches 2%, we recommend replacing UDP file transfer with more reliable protocols for data transmission if your network resource consumption allows to do it. For example, you can employ TCP or QUIC or any other more reliable protocols. So based on our results, even in case of really small network packet losses, the machine learning classification performance might not be tolerated in medical-related applications. And this question needs to be addressed by the both machine learning and medical community when they make their decisions based on the medical images. Thank you very much for the opportunity to present my work on this workshop, and I wish you a wonderful day. Thank you.